Hey there guys, it's Math&More tutorials here again and welcome back to another video. In this video I'm going to be talking about how to multiply complex numbers, divide them, and take one to the power of a number. So let's get started. So let's say we have this complex number, -3 plus 3i, and we have to square it. So in order to square this number, we could FOIL it out, or an easier method is we can convert it into trig form, and then we can do squared, because then we can use Demoivre's theorem and apply it. So yeah, let's get started. So we need to find r. So if you didn't know, in trig form, we have z is equal to r times the cosine of theta plus I sine of theta. So first we have to find r. So the way we find r is we take the square root of -3 squared plus 3 squared, which of course is equal to the square root of, so -3 squared is 9 plus 9, which equals the square root of 18, sorry. So this should equal, so 18 is 9 times 2, 9 is a perfect square, so we know this is just equal to 3 root 2. So we have r. Now we have to find our angle theta. We have to find our angle theta right here. So the way we find theta is we take the inverse tangent. Take the inverse tangent of b. So this is b, and this is a. So we take the inverse tangent of b over a, which is equal to the inverse tangent of 3 over -3, which is equal to -1, and this just equals -45 degrees. Now you might have noticed that this is very similar to transforming a rectangular coordinates to polar coordinates, so it's a very easy way to, you can really easily remember it. So before we use this as our angle, we have to first check something. So let's go to our complex plane. Remember, we're not on our Cartesian plane, we're on our complex plane because we're dealing with complex numbers. So we have -3 plus 3i, so that will be right. So that'll be like right here. Oops. Yes. Sorry for my bad drawing skills. Anyway, so our point is here, but what this is saying is -45. And that makes sense because tangent only goes from the first and second quadrant. So we can't use this because our point is in the third quadrant. So what do? We can just add 180 to this. So we can just add 180 to this, and we get so -45 plus 180 is 135 degrees. This is perfectly reasonable. Now we can substitute this in for theta. So we get 3 root 2 times the cosine of 135 degrees plus I sine of 135 degrees. And this equals z. Z is just a complex number. But what we're really trying to find, remember, in our original problem, we have this square here. So we're going to apply Demoivre's theorem. So what we can do is, so what we're really trying to find here is we're trying to find z squared. Now how do we find z squared? So what Demoivre's theorem says is the way we can take a complex number to a power is we take this r and we take it to that power. We take it to that power, and we do this. We do the angle theta times whatever our exponent is. So in this case we're multiplying by 2. So this just equals, so 3 root 2 squared is just 9. So remember, you have to distribute, so 9 times 2, which is equal to 18. And this just equals the cosine of 135 times 2. 135 times 2 is just 270. I hope I did my math correct. Yes. And then we have I sine of 270. I sine of 270 degrees, and you're done. Now, you could convert it back into standard form, but this is perfectly reasonable. Just leaving it in this form right here. So, yeah, I hope that helped, and let's do another example. Alright, so in this example, I'm going to be multiplying two complex numbers, z1 times z2, and let's say z1 is, I don't know, let's say z1 is 4 plus 6i, and let's say z2 is let's say z2 is 4 root 2 times the cosine of negative 45 plus I sine of negative 45. So before we can multiply this, we have to convert this into trig form. So remember, we have to use our identities. So we know that r is just equal to 4 squared, which is 16 plus 36. 16 plus 36. This just equals 52, the square root of 52, and 52 is equal to, let's see here, 52, I'm just going to grab out my calculator here. I could do the math, but I'm too lazy. Alright, so I'm just trying to see if there's any perfect squares. Yeah, so 4 is a perfect square, so this is equal to 2 root 13. And our angle is going to be the inverse tangent. It's going to be the inverse tangent of 6 over 4 or 3 over 2. So this should be the inverse tangent of 1.5. So this just equals to about 56 degrees. This about equals 56 degrees. So we have our trig form. 2 root 3 times cosine of 56 degrees. Oops, that should not. Let me just erase this really quick. Plus I sine of 56 degrees. And we have to multiply this. Remember, we have to multiply this by this. This. So our rule tells us that we can treat this kind of like exponents. What do you do when you multiply two bases, two of the same bases with exponents? You add the exponents. So what we do here is we multiply these r's, and then we just add these angles, and that makes it really simple. So what we can do is we can do 2 root 3 times 4 root 2. So 2 times 4 is 8. Root 3 times root 2 is root 6. So this is 8 root 6 times. So we have to do 56 degrees. So, hold on, wait. Yeah, we have to do 56 degrees plus negative 45 degrees. So 56 minus 45 is equal to 11. So this just equals the cosine of 11 degrees plus I sine of 11. And there we go, we're done. Now say this was, instead of multiplying these two numbers, let's say we're dividing them. We're dividing these two complex numbers, z1 and z2. So this is really similar, except now what we do here is we divide these r terms. So you divide 4 root 2 by 2 root 3, and then we subtract these two numbers. So negative 45 minus 56. So let's do that really quick. So 4 root 2 divided by 2 root 3 is 2 times root 2 over root 3, which is equal to 2 root 2 over root 3. Now I could rationalize this, but we'll just skip that step for now. And now we subtract here, so we subtract these two numbers. So we do, where is it? So we do negative 45 minus, we're doing minus 56. So 45 plus 56 is 101, or negative 101. So we just put that here. So we have cosine of negative 101 degrees plus I sine of negative 101 degrees. And yeah, that's pretty much it. So I hope you found this video helpful. If you did, please like and share this. So yeah, that's pretty much it, and thanks for watching.